And here we go. We're going rectangular to polar and polar to rectangular. We're going to go back and forth between the two types of coordinates. So if we think about a point on the xy rectangular, we'll go 12, 5. What would it be in polar? That means r and theta. If you wanted to find the r, you're really talking about the distance, and that would be the Pythagorean theorem. If you needed to find theta, you needed to use a little bit of trigonometry. There your point would be 13, 23 degrees. So let's look at an example. 2, -4, that's in rectangular. The radius by the Pythagorean theorem, you can see it. Theta by a little bit of trig. Makes sense, it'd be an angle in the fourth quadrant. And there you go. There's the polar coordinate. What if we wanted to go the other way? Let's start with a polar point and find the rectangular coordinate. You need to find an x and a y. Well, a little bit of trig, and you've got your two conversions right there. Looking at an example, if I gave you -2 -pi/6, work out a little bit of the trig, and then we use our conversion. If I wanted to find my x, it'd be r cosine theta, which is -√3/2. So my x value is √3. If I wanted to find r, I do the same, or y, I do the same thing, which is 1, and there's my polar coordinate. It's in quadrant 1, so is our rectangular coordinate. What if we're looking at an equation? The equation r = 4 should be a circle. If we convert it, sure enough, it is. What if we take a rectangular equation and try to go to a polar equation? Well, use the conversions that I gave you and write it as a polar.